Okay, this is review 5-2. It is for chapters 6-4, 6.5, and 6.6. This is all about solving radicals and different things with radicals and how to do with fractional exponents and things along those lines. So the way you get rid of a radical is by squaring it, and vice versa. The way you get rid of a square is by bringing it to a radical. So in this one, we're just going to go ahead and square both sides. That'll take care of the 2 minus the radical on the left. And 6 squared is 36, minus the 6, so it's negative minus 2, equals 34, and then flip your sign, x equals negative 34. Okay, and the one thing you always got to remember is I have to check this. So that is 2 minus negative 34. Does that really equal 6? Well, that really turns into a plus. That's 36. The square root of 36 is 6. So yes, this really is your solution. Number 2, hopefully you have figured out the pattern of these by yes. If everything is under a radical, just raise it to the power of that radical, and magically, the radicals go away. Actually, it's not magic, it's logic, but that's okay. Many people think that what's logical is actually magic. And from here, you just move your x's one way, and move your numbers, your units, the other way. So what we're going to do is I'm going to subtract the 2x. I'm going to subtract the 7, and I get back to my color. 7 and 5 make 12. Yeah, they make 12. Negative 12 equals 2x. I divide by 2, x equals negative 6. And then again, we're going to check it out. So, the cube root of 2 times negative 6 minus 5, does that indeed equal the cube root of 4 times negative 6 plus 7. 2 times negative 6 is negative 12, minus 5 is negative 17. So we got the cube root of negative 17. 4 times negative 6 is negative 24, plus 7 is also negative 17. So this is also the cube root of negative 17. So yes, this one also works. So therefore, this is a correct answer. Okay. Number 3, again, this is just solving for x. These are 2 and 3 step equations. It's not that big a deal. So we'll start off again, but this one we need to start off by dividing by that 2. So we'll divide by 2. We get the cube root of, that's a 2x minus 5 equals 5. We will go ahead and cube both sides to get rid of the 3. I said 3 and wrote a 3. So we get 2x minus 5 equals 125. Yes, that's an equal sign, and yes, that is a 5. Add the 5, so that's 2x equals 130. Divide by 2, so x equals, what is that, 65? Yep, 65. Last but not least, again, check it. So 2 third root of 2 times 65 minus 5 equals 10. Nope. That parentheses go there. 2 times 65 is 130, minus 5 is 125. Cube root of that is 5, times 2 is 10. So yes, this does work. Therefore, that is your solution. And last but not least, number 4. Okay. Remember, if I have any value of x to the 4/9, to get rid of that, I raise it to the reciprocal of both sides of the equation. Remember, to get rid of those? So that's how we do it. You raise it to the reciprocal. So I've got 1/4. No, sorry. First thing I do is get rid of a 4th. So I'll multiply both sides by 4. That'll cancel those out. So I got x to the 5/2 equals 8 times 4 is 32. So then I got to raise both sides to the 2/5, which I'm pretty sure that 32 to the 2/5 is 4. In fact, I'm almost positive, but I'm going to go ahead and put it in my calculator anyways. 32 to the 2 is indeed 4. Okay, and then yet again you have to check it. So that's 1/4, 4 to the 5/2 equals 8. Square root of 4 is 2. 2 to the 5th is 32. 32 divided by 4 is 8. Yep. This one works. So therefore, that is your solution. So nothing here canceled out. But that's just blatant solving for x. Let's pause real quick, and I'll go down and do 5 and 6 real fast. Okay, 5 and 6. A little more involved, but not by a whole lot. Again, think of this part right here as a big x value to get down to, and then take care of the exponent. So we'll start off by subtracting 5. Go away, go away. There we go. So that's 2x plus 11 to the 3 halves equals 59 minus 5 is 54. There we go. And then we go divide by 2, so it's x plus 11 to the 3 halves equals 27. And then to get rid of the radical, we will raise both of them to the 2/3. Remember, you flip the exponent to cancel those out. So that cancels out those. So I'm left with x plus 11 equals, the cube root of 27 is 3, 3 squared is 9, minus 11, x equals -2. Okay, and yet again, let's check it out, make sure it works. So I've got 2 times -2 plus 11 to the 3 halves, yep, 3 halves, plus 5, does that indeed equal 59? -2 plus 11 is 9, the square root of 9 is 3, 3 squared is 27 I mean. 27 times 2 is 59, plus 5, 50, I'm sorry, 27 times 2 is 54, plus 5 is 59. Yep, if you crunch this all down, you can shove that whole thing in your calculator just like that, and you will get 59. So that one works, therefore that is my solution. Okay, number 6. This one's a little more involved. If you recall, the way we do this is just by starting to square both sides. Go away. There it goes. Sorry, my program here is jacking with me. And the way we square both sides is, remember the binomials, you can't just square x and square the 1. You have to multiply it. What am I doing? You have to multiply it by itself. So that's x plus 1 times x plus 1. And I'll go over here to the right real quick and go x plus 1 times x plus 1. Well, 1 times 1 is 1, 1 times x is x, x times 1 is x times x is x squared. So these add up to x squared plus 2x plus 1. Okay? You can pause and look at that if you need to. So we got 3x plus 5 equals x squared. Let's clean that up. X squared plus 2x plus 1. Alright, from here you've got this x squared to deal with. So you're going to have to factor, use your quadratic equation, something. So what I'm going to do is I'm going to subtract the 5. we got to get everything over to one side. It is bas French accent right now. Sorry if you are from France. Here we go. 0 equals x squared minus x minus 4. Is that right? Does this one have no solution? 4 times 1, that's not going to be 1. 2 times 2, that's not going to be 1. What did I do? Give me a second, let me pause real fast. Nope, what I've done so far is correct. But we can't factor this because nothing multiplies to -4, but also adds to -1. So we're going to have to use our trusty -b plus or minus the square root of b squared all minus 4c all over 2a. So your quadratic formula. So here we go. That's is positive 1, -1. Yeah. So flip your b value. So that's positive 1 plus or minus the square root of b squared, which 1 times 1 is 1, minus 4 times 1 times -4 all over 2 times 1. Well, that's going to equal 1 plus or minus, that's what, -16, positive 16, that's square root of 17 over 2. And I'm just going to go ahead and tell you right quick. First things first, you're not going to get one like this on the test, but this is a really good problem. I like this. So your answers for this one are 1 plus or minus the square root of 17 over 2. Let's get you some really big funky decimal. But you're going to figure out really quick, if you plug that back in, that the negative form of it does not work. You plug it in. So, x equals 1 plus the square root of 17 over 2. I don't think you're going to get one like that on your test, but I can't promise that either. And there we go. Congratulations. If it had factored, we would just go ahead and factor this on down. We'll go ahead and factor this part on down right here and set them equal to 0 and test both points. But there you go.